Welcome back to the TPS podcast. TPS stands for trillions per second, named after the book. In this episode, we are holding the Rosetta Stone. We have a copy of the Master Lexicon for the TPS Protocol. We'll do a deep dive on the legacy code and how they map to the TPS Protocol. We have a big job ahead of us. So enough talk, and let's dive right in.
It is, yeah. It's great to be back. And you are absolutely right. This is a huge one. Because usually we're talking about the big, grand ideas, simulation theory, the physics of it all.
The what?
Exactly, the what. But today is all about the how. It's the instruction manual for the instruction manual.
It's the nuts and bolts. We are finally tackling the dictionary. And I have to admit, when I first opened this file, Appendix A, the Master System Lexicon, I was a little overwhelmed. It looks like the service manual for a UFO or something.
Well, in a way, it kind of is.
Yeah.
But I'd argue it's the single most important document we've looked at in this entire series.
More important than the origin story or the core physics.
I think so, yeah. Because think about it. In all those other deep dives, we kept hearing the author, C4 Chaos, talk about this new language. He kept saying, we need to refactor the old code.
Right.
But without this document, without this lexicon, all of that is just, it's just talk. It's aspirational. This thing we're holding, this is the translation layer.
The translation layer, I like that. That really clicks.
Without this, the rest of the manual is just gibberish. Or maybe, cool sci-fi fan fiction. This grounds the entire project in a workable, logical system.
Okay, so before we dive into the specific terms, and I've got a whole bunch of them circled here, I want to talk about the why behind it. I was reading TPS log 005, which is basically the dev diary for this part of the project. And C4 Chaos, he sounds absolutely wrecked, just completely exhausted.
It was a brutal process.
Yeah.
The log uses a very specific term for it. He calls it integration testing. And for anyone who works in software, that's where the nightmares happen.
Right, and it wasn't just like looking up words in a dictionary. The way he describes it, it's like trying to get an old Windows 95 machine to talk to a quantum computer.
That's a perfect analogy. You have this legacy code, the Abhidhamma, this incredibly complex 2,500-year-old Buddhist psychology.
Right.
And he's trying to map every single component of it to modern simulation theory. And you can't just plug them together. You get system crashes. You get fatal errors.
He mentions using digital synths, the AIs, to speed it up, but it sounds like that created its own problems.
Oh, for sure. The log implies the AIs were great at generating plausible-sounding mappings, but a lot of them were subtly wrong. They were philosophically incoherent, so the human oversight needed to go line by line and debug the dictionary itself. It must have been immense.
There's a line in there that says the lexicon was the code used to validate the integrity of the whole book.
Exactly.
So what we're holding isn't just a glossary for readers. It's the foundational code for the entire TPS protocol. If this document has a bug, the whole theory just falls apart.
It completely collapses, which is why this episode is so important. And it all goes back to solving what the project identifies in another file, 08 systemconfiguration.pdf. It calls it the ox cart problem.
Oh, I love this part. It's such a simple image, but it explains everything.
Yeah.
Can you break that down for us? What is the ox cart problem?
Okay, so you have to, put yourself in the shoes of someone trying to teach this stuff in, say, 500 BC. Let's say you're the Buddha. You've just had this profound insight into the operating system of the human mind. It's basically cognitive science.
Right.
But now you have to explain it. Who are you talking to? You're not talking to software engineers.
You're talking to farmers, to merchants, to people whose most advanced piece of technology is, well, an ox cart.
Exactly. The wooden wheel is cutting-edge tech.
Yeah.
So when you explain how the mind creates suffering, you can't talk about buffer overflows or latency. You have to use metaphors they understand. You talk about planting seeds of kindness.
Taming a wild elephant.
Taming elephants, lotus flowers, blooming in the mud, crossing a river on a raft. These were their high-tech metaphors.
Yeah.
And for that audience, it worked perfectly.
Sure.
But the manual makes this fantastic point. You, the person listening right now, you are a digital native. You run on high-speed silicon. You don't plow fields for a living. You debug code. You manage data streams. You understand what lag feels like in a video game.
So when I read an ancient text that tells me to plant the seeds of mindfulness, my brain just kind of files it under nice poetry. It sounds soft. It doesn't sound urgent or technical.
It sounds like decoration. And
Yeah.
that's the danger the manual points out. When the instructions sound like poetry, you treat them like poetry. You admire it, maybe you recite it, but you don't execute it as a command.
So the mission for this deep dive is to do exactly what the manual says. We have to purge the agricultural metaphors.
Install system logic. It's a driver update for a 2,500-year-old operating system.
I love the line it uses. You don't need poetry, you need a patch. So let's open up this dictionary. The lexicon is broken into these different segments, and I want to start with the one that's most fundamental. Segment 1, the operator. This is about redefining who you are in this process and what you're actually doing.
This is the big paradigm shift right here. It's the move from thinking of yourself as a spiritual seeker to a system administrator.
Okay, let's hit term number 1, the action. In the legacy code, this is called meditation, or the Pali word, Havana. But in the TPS protocol, it gets mapped to system administration, or even better, debugging.
This is such a profound change in mindset. Just think about the word meditation. When you hear that word, what's the first image that comes to your mind, honestly?
A spa. I'm picturing someone on a nice cushion, maybe there's a little waterfall, some gentle music. It's peaceful. It's about taking a break from my stressful life. It's me time.
Exactly. The cultural connotation is one of relaxation, of zoning out. It's sold as a lifestyle accessory, like a yoga class or getting a massage.
Right.
And the goal, therefore, is to feel better, to feel relaxed. So if you finish your 20 minutes on the cushion and you don't feel relaxed, if you feel more agitated, you immediately think you failed.
Oh, 100%. I sit down, my mind is just a hurricane of thoughts about my to-do list, and I think, I am so bad at this. I'm not a meditative person.
But look at the TPS reframe. System administration. That does not sound like a spa day.
Not at all. It sounds like work. It sounds like my day job.
It implies an active, technical, often frustrating job. If you're a sysadmin and you get an alert that a critical server is crashing, are you logging in to relax? To find your bliss?
No, you're logging in to find the broken line of code. You're hunting for the error. You're stressed.
You are the lead admin of your own biological operating system. And the manual has this one line, this constraint that just stopped me in my tracks when I read it. It says, if you aren't sweating, you aren't debugging.
Wow. If you aren't sweating, you aren't debugging. That's intense.
That's the whole ballgame right there. This isn't stress relief. It's malware hunting. The text explicitly defines the action as the active process of hunting down and deleting the self-malware. Okay. If you're actually looking for a rootkit virus that's buried deep in a complex system, you aren't zoning out. You are hyper-focused. You're staring at logs, looking for anomalies, trying to find the source of the crash. It is hard work. It requires effort.
So let's apply that. I sit down to practice, and my mind is a total mess. I'm agitated. I'm thinking about some argument I had. I'm annoyed. The SPA model says that's a failed session, but the sysadmin model says, what?
It says, congratulations, you found the bugs. The agitation is the error log. The racing thoughts are the system latency. You're looking at the performance monitor and seeing that the system is unstable and crashing. That's not failure. That's the diagnostic tool working perfectly.
So the difficulty becomes the data.
The difficulty is the point. You can't debug a clean system. You can't find a bug if the program isn't running. You need the chaos to see where the code is broken.
That completely flips the script.
That is so useful.
Okay, that leads directly to the next term. Why are we doing this? If I'm a sysadmin sweating over the code, what's the end goal? This brings us to term number 2, the goal state. In the legacy code, this is the big one. This is the whole point. Enlightenment, or the Pali words, nirodha or nibbana.
And that word enlightenment just carries so much baggage, doesn't it?
So much. It sounds magical. It sounds like something for saints in a cave, not for me. And it sounds so binary. Either you have it or you don't. Either you're the Buddha under the Bodhi tree, glowing, or you're just me.
It feels unattainable. And frankly, it feels like it requires a degree of faith. It's a trust us kind of goal. Just do this for 40 years and maybe you'll achieve this mystical state.
Right. But the TPS protocol, it renames this to something so brutally simple. Zero lag.
Zero lag.
It immediately renders the ultimate spiritual goal as a technical optimization problem.
Exactly. It yanks it out of the clouds and puts it right on your desktop.
I love this because lag is something I have a direct, visceral experience of. I know what it feels like when my internet connection is slow, or a video call is stuttering, or my game is dropping frames. It's friction. It's annoying.
And the system definition in the lexicon is incredibly precise about what causes that lag in your mental OS. It says, buffering is identified as craving aversion.
Okay, let's unpack that one. How is craving an act of buffering? That feels like a bit of a leap at first.
It does, but think about it technically. What is buffering? when you're watching a video. It's when your device pauses the playback of the current data packet
Yeah.
to wait for a future data packet that hasn't arrived yet.
Okay, yeah, the little spinning wheel.
Right. Now think about craving.
Yeah.
You're stuck in a boring meeting at work. You are physically in that room, that is the current data packet, but where is your mind?
It's thinking about being at home on the couch.
It's trying to load a future frame. It's
Yeah.
projecting a reality. I want to be on my couch that does not exist yet.
Yeah.
You are actively resisting the present moment data stream,
Yeah.
the meeting, and trying to buffer a future one. The couch.
So my internal CPU is just spinning its wheels, creating friction.
It's trying to process a file that isn't in the cache. That's lag, that's heat, that's inefficiency. The system stutters because it is out of sync with the real-time flow of reality.
Mhm.
And aversion is the same thing, just in reverse pushing away the current frame instead of pulling a future one.
And zero lag is when that whole process just stops.
The definition is beautiful in its simplicity. The state where the system processes the flux reality in real time without buffering. When that friction of pushing and pulling vanishes, the system just runs cool. It runs fast. It's not about being holy. It's about being efficient.
It totally removes the morality from it. It's not that craving is sinful or you're a bad person for wanting the meeting to end. It's just, it's inefficient code. It's a resource hog.
Exactly. A supercomputer doesn't judge inefficient code as bad. It just identifies it as suboptimal and corrects it. Enlightenment isn't a moral achievement. It's just peak system performance.
Wow. Okay. So we have the job, system admin, and I have the goal, zero lag. Now, we need to talk about the environment. Where does this work actually happen? This brings us to segment 2, safe mode versus live operations. This section, for me, clarified so much confusion about different styles of practice.
This is a really critical distinction. It's the old school difference between samatha, which is concentration practice, and vipassana, which is insight. But the manual, again, uses much clearer, more functional terms.
So term 3, the shelter, legacy code, concentration, samatha, or more specifically, the jhanas, TPS Protocol, safe mode, or sandbox mode.
Right. So in the traditional world, the jhanas are these legendary states of deep, blissful absorption. The idea is you focus your mind so intensely on one single point, like the breath, that literally everything else in the universe disappears.
And people say it's incredibly pleasurable.
Extremely. It's described as a profound natural high, more blissful than anything you can experience in normal life. People can spend their entire lives just trying to master these states.
And TPS just looks at it and goes, yep, that's safe mode.
That's safe mode. Or, to be more technical, single-threaded processing. Think about when you boot your computer in safe mode. What happens?
It loads only the absolute essential drivers. No fancy graphics, no internet connection, no background apps chewing up RAM. It's very stable and very quiet.
But what can you actually do in safe mode?
Not much. You can't play a high-performance game or edit video. You're there to run diagnostics, basically.
Exactly. And this is where the manual drops another bombshell. It refers to a deprecation notice from the source. It says, about the jhanas, it feels euphoric because the virus of the self is temporarily quarantined.
That is a brutal take. It's saying the only reason you feel so good in these deep states is because you've basically locked the main source of all your problems in the basement for an hour.
You haven't deleted the virus. You haven't even found it. You've just booted into an environment where the virus can't execute. All the complex processes of your life, your job, your relationships, your anxieties, they're all offline in safe mode. So of course it feels good. The source of the lag is dormant.
But the manual has that very specific warning attached. Do not get addicted to the sandbox.
And that is the trap. It is a shelter, not a solution. It's a diagnostic tool, not the repair itself. You cannot delete malware while you're hiding in safe mode. Eventually, you have to reboot back into normal mode, into the chaos of your life, to actually find and patch the damn thing.
I think so many people make that mistake. They think the whole point of practice is to get to that quiet, blissful place and just stay there.
And then they get off the cushion, someone cuts them off in traffic, and they're instantly filled with rage, and they think, my meditation isn't working.
Right.
No, your meditation worked perfectly. You achieved safe mode. But now you're back in live operations, and you haven't actually fixed the buggy code that generates road rage.
Okay, so if safe mode isn't where the real hacking happens, what's the minimum requirement to even start? That brings us to term 4. The connection. In the legacy code, it's upakara samadhi, or access concentration, the TPS protocol calls it. Signal lock.
Signal lock, defined as pure connection stability.
In the, the hardcore dharma community where this stuff comes from, achieving access concentration is talked about like it's this huge spiritual milestone. It's a really big deal for a lot of people.
Oh, it's a holy grail for beginners. People strive for it for years. But in the TPS framework, the manual is almost dismissive. It calls it merely the minimum system requirement.
That's a serious reality check.
It is. Think about it like this. You're about to download a massive multi-gigabyte file. If your Wi-Fi signal is choppy and keeps cutting out, what happens?
The download fails.
Right. Signal lock is just the moment the Wi-Fi icon turns solid green. It means you have a stable, uninterrupted connection.
The visual they use in the manual is a dashboard light turning from red to green.
Exactly. You cannot run the security scan until the background noise, what the legacy code calls the hindrances, like desire, aversion, sleepiness, drops to an acceptable level. You need a clean signal. But getting the clean signal isn't the work itself.
It's just getting ready to work.
It's like putting on your safety goggles before you start welding. The goggles aren't the welding. They're just the prerequisite so you don't blind yourself.
Okay, so the light is green. We have signal lock. We're not distracted. Now it's time to actually run the program. This is segment 3, the execution.
And this is where the language gets really aggressive and cool.
This is where we go from stability to raw speed. This is where the trillions per second idea really comes online.
Term 5, the boost. Legacy code. Absorption, samadhi, TPS protocol, overclocking.
Overclocking, yeah.
Yeah.
For anyone who's ever built a gaming PC, you know exactly what this means. You're intentionally pushing your hardware to run at a higher clock speed, a higher frequency, than the manufacturer's default settings.
You're forcing more computational cycles per second through the CPU?
Yeah.
But why? Why do we need to overclock our own brains? Why can't we just sit back and observe reality at a normal, relaxed pace? Because of the simulation's refresh rate. The entire project is named trillions per second for a reason. The core hypothesis is that the data stream of reality is refreshing at a speed that is almost incomprehensible to our normal consciousness.
And our default brain speed is, what? A dial-up modem.
Pretty much. Evolution designed our perception for survival, not for seeing ultimate reality. We're probably running at, maybe the equivalent of 60 frames per second on a good day. Our brain takes this insanely fast stream of data and deliberately blurs it together to create a smooth, coherent, and slow-moving movie. It's a survival feature.
So overclocking in this context means stabilizing the mental hardware to a point where it can process that data stream at a much, much higher frequency.
If you try to process reality at your normal default speed, you miss the packets. You miss the tiny momentary glitches in the matrix where the self-program is constructed and reinforced. The virus hides in the blur. It hides in the gaps between the frames.
So to catch the malware, you have to be faster than it. You need to run a high-speed diagnostic.
You need to be able to see the individual frames of the movie instead of just the movie itself.
And once you're running at that overclock speed, you deploy the actual exploit, term 6, the technique, legacy code, Sukha Vipassana or dry insight, TPS protocol, hot patching.
Hot patching.
I love this term so much. It sounds dangerous. It sounds like something you shouldn't be doing.
And in a way, it is. The system definition is live debugging, running the exploit while the system is still online and under load.
This connects right back to that safe mode versus live operations distinction.
Perfectly. The other path, the wet path of tranquility, that's like taking the server offline for maintenance. You freeze the data stream, you pause the movie to analyze a single static screenshot. It's safe, it's calm.
Right.
But the TPS protocol follows the dry path. You don't take the server offline. You don't pause the movie. You debug the raw live data feed as it's screaming past.
And the source material explicitly states the trade-off here. It says, we prioritize code quality wisdom over system stability, tranquility.
And that one sentence explains everything about why this style of practice can feel so intense, so jarring. It explains why it's called dry insight. It's not lubricated by all that bliss from the jhanas.
You're not in the sandbox anymore.
You are in the trenches of the live production environment. You're watching the data packets of reality fly by, pain, anxiety, thoughts, sounds, and you are trying to patch the core operating system on the fly. It's chaotic. It's rough. But, as the text says, it is real.
Because life is a live feed. You can't put your boss yelling at you on pause. You can't pause a sudden headache. You have to be able to run the debug protocol in real time.
Exactly. If your enlightenment only functions when you're alone in a silent room with your eyes closed, then it's not a patch. It's just a pause button. Hot patching is designed to work in traffic. It's designed to work in the middle of an argument.
It's the difference between doing a choreographed martial arts dance in the air
And actually sparring with someone who's trying to hit you. One is theory, the other is application. Try Insight's application.
Okay, this is amazing. So we've overclocked the system, we're hot patching it live, but what are we actually looking at? What is this data stream made of? This takes us to segment 4, the physics of the simulation.
The granular nature of reality itself, according to the protocol.
Term 7, the metric, legacy code, kana or momentary concentration, TPS protocol, trillions per second, the refresh rate.
And here we are, right back at the title of the whole project. It's not just a cool, futuristic-sounding name. It is the fundamental metric of reality.
The core context here, as I understand it, is that reality is not solid at all.
Not in the slightest. We experience the world as being made of persistent solid objects. This table, this microphone. But the TPS protocol, and its source in the Abhidhamma, says no. That's an illusion. Reality is a fluid, flickering stream of 3D data packets that are arising and vanishing at this unbelievable speed.
So the illusion of solidity is just
Motion blur. The text says it perfectly. What we see as the world is just motion blur. Think of a ceiling fan. When the power is off, you can clearly see 3 distinct blades with empty space between them.
right.
Now you turn it on high. What do you see?
A solid, blurry disk.
Is it a solid disk?
No.
Of course not.
Yeah.
It's still just 3 blades with a lot of empty space. Your visual processing system is simply too slow. Your frame rate can't keep up, so your brain smears the data together to create the illusion of a solid object.
So the practice, the overclocking, is about developing the perceptual frame rate to be able to see the gaps between the fan blades of reality.
Yes, to see the black screen between the frames of the movie, because the self-virus, the illusion of a solid you, it lives in the blur. If you can slow it down enough to see the individual frames, the whole illusion of a persistent me it falls apart.
And speaking of the frames, or the pixels, we have to talk about the kalapa.
The Karapa, yeah. This is referenced in tpsch01.pdf.
In the legacy code, a kalapa is described as the smallest possible unit of matter. It's like an atom, but even more fundamental. The TPS protocol maps this to a voxel, or data packet.
And I love that they chose voxel instead of pixel. A pixel is flat, it's 2D. A voxel has volume. It's a 3D pixel, like a block in Minecraft. It implies that reality is a 3D grid of these flickering data packets.
There was a really cool point in the notes here, using object-oriented programming as an analogy, the difference between the instance of an object and its attribute.
This is a bit nerdy, but it is absolutely crucial for getting your head around this. The text explains that the kalapa, the voxel, is the instance. It's the object container itself, but the qualia, the actual feeling of it, the color, the sensation, that's just an attribute, a variable.
Can you give me a simple non-code example of that?
Sure. Think of a car. The physical car is the object, the instance. The color red is just an attribute. You can change that attribute, you can paint the car blue, and it's still the same fundamental car object. In code, you'd write car.colorRed.
Okay, got it.
Now, apply that same logic to your mind. You feel a wave of sadness. Our default programming is to fuse with that feeling. We think, I am sad. The TPS protocol says, no, that's a syntax error. What's actually happening is that a data packet, a kalapa, is passing through your system, and its emotion attribute is currently set to sad. Kalapa.emotion, it's sad.
So why is that distinction so important? It seems subtle.
It's everything. Because we get lost in the content. We get lost in the redness of the car. We get lost in the sadness of the emotion. We think the attribute is the reality. But the protocol trains you to see the underlying object structure. It wants you to see that kalapa.emotion equals sad is just a temporary variable. It's a flickering line of code. It's not a fundamental, solid property of you.
It totally detaches you from the story, makes you focus on the structure. It sounds very cold and clinical, but also incredibly freeing.
It is. You stop drowning in the drama of the content and you start analyzing the code that's generating it. You realize that pain isn't a personal affliction. It's just a data packet with the attribute sensations set to a high-intensity value.
This is so incredibly detailed. And it brings me back to the question of why? Why go to all this effort? Why build this massive, complex dictionary? This brings us to segment 5, the why behind the lexicon.
And for that, we have to go back to that dev log, TPS log 005.
Right. We know the author used AIs, the digital synths, to help accelerate the translation process.
But the log reveals that the goal wasn't just to make a handy glossary for human readers. That was a side effect. The real ambition was much, much bigger. The author wants to build a parser.
A parser?
Yes. In computer science, a parser is a program that takes in a chunk of text, analyzes its grammatical structure, and converts it into a format that a computer can actually understand and execute. The author's goal is to be able to feed any legacy spiritual text.
Any of them.
Any of them. A cryptic Zen koan, a dense passage from the Pali Canon, a chapter from a modern teacher like Daniel Ingram. You feed it into an AI and you give it one command. Run TPS Protocol.
And the output would be a clean, logical, sysadmin-ready report.
Precisely. The input is, my heart aches with longing for what is lost. The output is, system error. Latency detected. CPU cycles are being consumed by a persistent process attempting to access a null pointer to a deprecated memory address, the past.
That's absolutely wild. It's effectively weaponizing the translation layer to strip the poetry and dogma out of any spiritual teaching and reveal the raw algorithm underneath.
It creates a universal interface for contemplative technology. It doesn't matter if the original programming language was Pali or Sanskrit or Japanese. The lexicon allows you to compile all of them down to the same underlying system architecture.
And that note in the log about integration testing makes even more sense now.
It has to be perfect. The author mentioned spending endless cycles patching the lexicon itself, because if your core definitions are even slightly off, if you map nibbana to the wrong system state, for instance, then your parser will generate fatally flawed code.
The entire system would crash.
So the lexicon is the foundation. It's the code that validates the integrity of the whole book. It's the Rosetta Stone, like you said at the top. Once you have that key, you can decipher everything else.
Okay, let's run through a few more of these critical mappings before we start to wrap up. Segment 6, other critical mappings. These are pulled from the tpsch01.pdf file. Let's start with the 3 system signatures.
Right. In the legacy code, these are known as the 3 marks of existence: anicca, dukkha, and anatta. Anyone who's even briefly studied Buddhism has heard these terms. They're the absolute cornerstones of the philosophy.
But the TPS protocol, it doesn't frame them as philosophy. It frames them as system signatures, as diagnostics.
Let's take the first one, anicca. The classic translation is impermanence. The TPS translation is simply the flux.
Or volatility, the refresh rate.
It's the fundamental law of the system. Nothing stays on the screen. The data in every voxel is constantly being overwritten. There is no save button in the universe. Everything is volatile memory, like RAM. Nothing is ever written to the hard drive.
That's a great way to put it. Okay, the second one, dukh. Legacy translation is suffering or dissatisfaction. The TPS translation, system latency.
We touched on this already, but it's worth repeating. It's the friction generated by resisting the flux. It's the lag caused by the processor trying to hold on to a frame that's already gone. Suffering sounds personal, it sounds like a punishment. Latency just sounds like a performance issue that needs to be optimized.
And then there's the big one, the third signature. Anatta, legacy translation, no self or non-self. TPS translation, the null pointer.
This is it. This is the most critical, most mind-bending diagnostic in the entire system. This is the one that, when you truly see it, breaks the whole illusion.
Okay, the null pointer. As a non-coder, you're going to have to walk me through this one very carefully. What is a null pointer?
Okay. In programming, a pointer is basically a variable that, instead of holding a value itself, holds the memory address of where a value is stored. Think of it like a signpost that says, the data you're looking for is over there, in that specific box.
Okay, a signpost, I get that.
A null pointer is a signpost that points to nothing. It points to address 0. Null. It's a signpost that leads to an empty lot. The code tries to follow the pointer to retrieve the data, but when it gets there, there's nothing in the box.
So it's an error, a crash.
It's a fatal error in many systems. Now, apply that to your own mind. The program of your consciousness is constantly running operations that reference an object called user, or me. I am hungry. I am happy. I am listening to this deep dive.
Right. I have a very strong sense that I am the one doing the listening. I'm the center of my own universe.
The system points to that perceived center of experience. It expects to find a solid, continuous entity there, the little driver in the seat of the brain. But the deep diagnostic, the overclocked observation of hot patching, reveals that the signpost is a null pointer. The folder is empty.
There is no user. There's only the processing.
There is only the data stream of sights, sounds, and thoughts. The user is a ghost in the machine, a hallucinated object that the system keeps looking for but can never find because it was never there to begin with. And realizing that, truly seeing that you are a null pointer, that's the moment you get root access to the system.
It's both terrifying and completely liberating at the same time.
It's the ultimate truth of the system architecture, and it explains so much. It explains that constant low-level feeling of anxiety or lack that people have. We're looking for a self that isn't there. But once you accept the null pointer, you stop trying to find it. You just let the code run.
Let's finish with the hardware specs. The The text maps the senses, the Salayatana to input ports.
Pretty straightforward. Eyes, ears, nose, tongue, body. They're just the USB ports where external data enters the system.
But the really cool one is the sixth sense. In Buddhism, the mind itself is considered a sense organ. You don't think thoughts, your mind senses thoughts, just like your eye senses light.
And the TPS protocol maps this to the terminal, or the command line.
The mind is just input port number 6.
This is so profoundly important to grasp. We identify with our thoughts completely. I think, therefore I am. The TPS protocol reframes this completely. It says, no, thoughts are just data packets arriving through port 6. They are just lines of text scrolling up the screen on the terminal.
You are not the text that's scrolling by.
You are not the text. You are not the terminal. You are, well, as we just established, you are the null pointer the text is supposedly about.
Right. You're the space where the text appears, but there's no actual reader sitting there.
That's the code. That's the whole architecture.
Man. Okay. Let's try to summarize this. We've covered a tremendous amount of ground.
We really have.
We've gone from meditation to system debugging, from enlightenment to zero lag. We've reframed blissful states as safe mode. We've basically handed the listener a dictionary that rewrites the entire contract for how to engage with their own mind.
It is a massive, massive shift in perspective. You're moving from a model that feels like personal salvation
Saving my soul.
to a model of system optimization, fixing the code.
It's pragmatic, it's stripped of all the woo-woo stuff, it's actionable, and honestly, it just sounds cooler.
It removes the guilt. It removes the mystery. It removes the need for faith. It just leaves you with the work. It leaves you with the command line blinking, waiting for input.
So here's the call to action for you, the listener. We have only scratched the surface today. We've picked out some of the greatest hits. But there is a full Master System Lexicon in Appendix A of the manual.
It's a dense read, but it is worth every second you spend with it. There are hundreds of terms in there, all mapped out with this level of precision.
So we encourage you to use this. Use it as your decoder ring. The next time you read a spiritual text, old or new, or listen to a talk, try running it through the TPS protocol in your head. Ask yourself, what's the system logic here? Where's the agricultural metaphor? How would a sysadmin describe this problem?
Update your drivers. Stop trying to navigate the information superhighway with an ox cart.
And we want to leave you with one final, provocative thought. Something for you to chew on until our next deep dive.
We've given you the dictionary. We have shown you, using the system's own documentation, that the entity you call you is identified as a null pointer in the core architecture.
The text is unambiguous. The folder is empty.
So the question is this. Now that you know the self isn't the admin, that it's just a buggy, resource-hogging background process, are you going to keep letting it run?
Are you going to keep letting that piece of malware consume 99% of your CPU cycles, generating all that heat and lag?
Or are you ready to open the terminal and start the hot patch?
The cursor is blinking. The choice is yours. Thanks for listening to this deep dive into the TPS Master Lexicon. Keep hacking.